Hello everyone, welcome to this video lecture of Geotechnical Engineering. This is Sukamal Ghosh, Assistant Professor, Civil Engineering Department, Greater Kolkata College of Engineering and Management, JS Group. In our last lecture, we have discussed about the analysis of active stage and also calculated the active earth pressure using the Bell's analysis of lateral earth pressure for the C5 soil. Now in this particular video, we will discuss the analysis of passive stage, and we will also know how to calculate the passive earth pressure using the Bell's analysis. Now in the analysis of cohesionless soil, we didn't calculate the passive earth pressure separately. We just replaced the coefficient of active earth pressure with the coefficient of passive earth pressure, and we got the passive earth pressure, right? But in the case of the cohesive soil, we need to calculate the passive earth pressure separately. But why? Let's discuss. Passive stage, okay? Better to write it as analysis of passive stage. Okay, analysis of passive stage. So first let me consider here is a retaining structure which is retaining a cohesive soil. Okay, so this is the retaining structure. And it is retaining a cohesive backfill, right? So this is the cohesive backfill. Okay, now let me also consider the height of this retaining structure is h. Okay, and the unit weight of the soil is gamma. So let me write it here. The height of the retaining structure is h, and the unit weight of the soil is gamma. Okay, so we know that sigma 1 is equals to sigma 3 tan square 45 degree plus 5 by 2, right, plus 2c tan 45 degree plus 5 by 2. Okay, basically this soil is actually C5 soil. Okay, now we have discussed the state of stress at passive stage, right? See, in the passive stage the sigma 1 is pp and the sigma 3 is sigma v, right? So let me put it here. So sigma 1 is pp and this sigma 3 is sigma v. Okay, so it is tan square 45 degree plus 5 by 2 plus 2c tan 45 degree plus 5 by 2. Okay, now if you recall, we had also derived that the Kp means the coefficient of passive earth pressure is equals to the tan square 45 degree plus 5 by 2. Okay, so let me write it here, that sigma v into Kp, because this whole expression is nothing but the Kp, right, means the coefficient of passive earth pressure, plus 2c, and again this expression is nothing but the square root of Kp, right? See, if the tan square 45 degree plus 5 by 2 is equals to Kp, then the tan 45 degree plus 5 by 2 is square root of Kp, right? So let me write it here, square root of Kp, okay? Now this vertical stress will nothing but the effective stress, okay? So we know the effective stress is height into the unit weight. So here the height is h and the unit weight is gamma. See, the height is h and the unit weight is gamma, okay? So let me write it here, that h into gamma, okay, this is the sigma v into Kp plus 2c root over Kp, okay? So if you more simplify it, you will have Kp into gamma into h plus 2c root over Kp, okay? So this is the expression for the passive earth pressure for cohesive soil, okay? Now in this particular expression, you may observe that this portion is depends upon the height of the retaining structure, but this portion is not depending upon the height of the retaining structure, okay? So let me write it here, that this expression is depends upon the height of retaining structure, right? But this portion is not depend upon height of retaining structure, okay? So since this particular expression is not depends upon the height of structure, throughout the height of the retaining structure, the pressure distribution for this expression will be same. So let me draw it here. So this is the retaining structure, and this is the backfill, okay? Now for this expression, the passive earth pressure will be same throughout the depth, right? So this will be the pressure distribution diagram for the expression of 2c root over Kp, okay? Now if you consider this particular expression, we know that it depends upon the height of the retaining structure. See, this is the height of the retaining structure, right? So actually in this point, means at the top of the backfill, actually h is equals to 0. It means at the top this particular expression is 0, right? So at the top this Kp gamma into h is 0, right? But at the bottom, means at here, this expression will be Kp into gamma into h, okay? So that is why the pressure distribution diagram for this expression, that is Kp into gamma into h, will be this, okay? So this is the pressure distribution diagram for this expression Kp into gamma into H. Okay, so let me write it here. For this portion, the pressure is same throughout the depth. Okay, but for this case, the pressure is varying with the depth H. Okay, so let me draw the total passive earth pressure distribution diagram. So if we combine that passive earth pressure distribution diagrams, then you will have this passive earth pressure distribution diagram. Okay, so this portion is for 2c square root of Kp, and this portion is Kp into gamma into H. Okay, so the total passive earth pressure for the cohesive soil is Pp is equals to 2c square root of Kp plus Kp into gamma into H. Okay, now we need to calculate the total resultant passive earth pressure force. Okay, see, for this rectangular passive earth pressure distribution diagram, the resultant passive earth pressure force will act here, right? This suppose Fp1, okay, and this height is suppose y1, where y1 is h by 2, okay, and due to this triangular passive earth pressure distribution, the resultant force will act, suppose here it is Fp2, okay, and this height is, let me consider y2, where the y2 is h by 3, right? So what I actually want to mean, see, this is the rectangular pressure distribution diagram, so that is why at h by 2 depth a resultant force, that is Fp1, is acting, okay, and since this is the triangular distribution of pressure, the resultant force will act here at a depth of h by 3, right? So what will be the value of this Fp1? The value of the Fp1 is nothing but the area of this rectangular pressure distribution diagram. So let me write it here. The Fp1 will be the area of this rectangular portion, right? So the base width is 2c square root of Kp and the height is h. So it will be h into 2c square root of Kp, right? And the Fp2 will be the area of this triangular pressure distribution diagram. So the base width is Kp into gamma into H and the height is h. So this will be half into h into Kp into gamma into h. So if you simplify it, you will have half into Kp into gamma into h square. So this is Fp2. So this is FP2 and this is FP1. Okay, so this FP is acting at a depth of y1 from the base, where this y1 is h by 2, and this FP2 is acting at a depth of y2 from the base, right, where this y2 is h by 3. Okay, now what is the total resultant force? See, the total resultant force, that is FP, is FP1 plus FP2. Okay, so the FP1 is h into 2c square root of Kp, and the FP2 is half into Kp into gamma into h square. Okay, so this is the total resultant passive earth pressure force. Okay, now at which depth this total resultant passive earth pressure force is acting? Suppose at a depth of y bar, this total resultant passive earth pressure force is acting. Okay, so at y bar depth the FP is acting. Okay, so this y bar can be given by the FP1 into y1 plus FP2 into y2 divided by the FP1 plus FP2. Okay, where y1 is h by 2, y2 is h by 3. Okay, so basically the FP is the resultant force, which is equals to the FP1 plus FP2. Okay, and this is acting at a depth of y bar. Okay, so for this whole analysis of passive stage, you may observe for the case of passive earth pressure, we do not need to think about the HC or the critical depth. Okay, see, for the analysis of active stage or for the calculation of active earth pressure, we need to think about the critical depth, right, because the tensile cracks are occurring at the time of the active stage. Okay, but at the passive stage there is no tensile cracks are going to occur, hence we do not need to calculate the ZC or the HC. See, there can be another explanation that since the passive earth pressure cannot be zero, unlike the active earth pressure, we don't need to calculate this HC or the ZC. Okay, so let me write it here. Okay, for the analysis of passive stage, we do not need to worry about the calculation of critical depth. Okay, so this is, suppose these are some notes. Okay, this is one. Then number 2 will be in passive stage, no tensile cracks will occur. So we don't need to calculate the ZC, means the depth of tensile crack, right? Okay. Now the basis of this 2 point is the passive earth pressure cannot be zero like the active earth pressure. This active earth pressure can be zero, right? We have discussed when we analyze the active stage. Now if you recall our lectures on the analysis of cohesionless soil, for the cohesionless soil we calculated the active earth pressure values, and we discussed that if you want to calculate the passive earth pressure values, then we just need to replace the active earth pressure coefficient or the coefficient of active earth pressure, that is Ka, by the Kp. Okay, for the cohesionless soil, then we can derive the expression for the passive earth pressure, okay, for the cohesionless soil. But you may observe in the analysis of cohesive soil that we need to calculate the active earth pressure and the passive earth pressure differently, right? We just cannot use the same expression only by replacing the Ka with Kp, okay? So let me write it here. For the cohesive soil, we can't use the same expressions for passive earth pressure and the active earth pressure only by replacing Ka by Kp or maybe Kp by Ka, unlike the cohesionless soil, okay? So these are the difference between the analysis of cohesive soil and the cohesionless soil. So what I actually want to mean that for the analysis of cohesionless soil, you don't need to derive the expressions for the active earth pressure and the passive earth pressure differently. You just need to calculate either only the active earth pressure or only the passive earth pressure. Suppose you calculate or you derive this expression for the active earth pressure, then to calculate or to derive the expression for the passive earth pressure, you just need to replace this Ka with Kp. So it is so simple. But in the case of cohesive soil, you need to calculate or derive the expressions for the active earth pressure and the passive earth pressure differently. You just cannot use the same expression for the active earth pressure and the passive earth pressure only by replacing the Ka, means the coefficient of active earth pressure, with the coefficient of passive earth pressure, okay? So this is it for today. In our next lecture, we will discuss about the analysis of sheet piles. Till then, stay safe and stay happy. Thank you.